Thank you everyone for joining. I'm Rama. I'm working as a principal data scientist at Meesho. Uh, yeah, I've got a bad news and a good news for you. So the bad news is that this session is not going to be about generative AI, right? Which is the ending topic. But the good news is that to explain, to test out new ideas like generative AI in production systems, right? So if you have a new idea, we need to make sure that we safeguard our production systems to make sure that go into production and screw up the production metrics, right? So that's going to be the topic of this talk, right? So a bit of context about Meesho. So Meesho is an e-commerce company in India. Some numbers. So it's the world's fastest shopping app to cross 500 million downloads. We have got more than 140 million transacting users, more than 1.3 million active sellers, and more than 120 million product listings, right? And the good news is that we recently turned profitable, right? Cool. Let's go back to our agenda. What is A/B testing and why do we need A/B testing, right? So let's start with a simple question, right? So let's take up the simple example. We have an e-commerce app and these are the simple metrics that we track, right? You have number of clicks per user, you have number of orders per user, CTR, orders per view, so on and so forth, right? So the system is running, right? But let's assume that you have come with an awesome solution and you know that in some other company this solution has worked, right? So you are super confident of the solution, you directly go ahead and scale it up, right? But the bad news is that all the metrics go down, right? You can see that number of clicks per user has gone down from 15 to 12, right? So on and so forth. Like all the metrics have tanked, right? I mean, this is a disaster, right? Such kind of things should never be encouraged, right? So the bottom line here is that everything should be tested, right? And to put things into perspective, like marketing team spends thousands of dollars in order to acquire users, in order to make old users open the app via retargeting, via FB campaigns, so on and so forth, right? And here, in one single day, we have destroyed this metric, right? It has gone down by 20%. Right? So this is the issue with scaling up things without testing, right? So that's where A/B testing comes into picture, right? So what is A/B testing? So A/B testing is if you have an idea, before scaling it up to 100%, you test it on a small audience, right? So let's say 2% of the audience, right? Where control has 2% traffic and variant also has 2% traffic. You let it run for a couple of days, and if all the metrics are looking fine, both primary and secondary, you then scale it up, right? So this is the basic idea behind A/B testing. Although the idea is pretty simple, when it comes to implementation, it is quite hard, right? So I want to focus on that, right? So this is going to be the agenda. I'll try to answer all the basic questions around the A/B testing. So I'll start with sample size calculation. How many users do you need in an A/B test? And then I'll talk about the three key challenges that we faced. That is how to assign users to experiments. And second, how do we create audience so that we can conduct a lot of experiments. And third one, how to assign users to treatment groups so that they are homogeneous in nature, right? So these are the three key challenges that I'll try to explain. And this is inspired by our journey. So we built A/B testing platform from scratch. I'd like to talk about that, right? And I'll finally conclude that with statistical significance calculation and some A/B experiment defaults and the impact that we have created in the company, right? Cool. So let's start with sample size, right? So how many users do you need, right? So obviously it cannot be static, right? You cannot say that 1,000 users or 1 million users is good enough for an experiment, right? So what does it depend on? Well, there is a nice formula here where, ignore the first formula. It's a bit scary, but focus on the last one, right? N is equal to 15.7 into sigma square by delta square, where N is the number of users required and sigma square is the variance. Delta is the mean of the metric multiplied by minimum detectable effect, where minimum detectable effect is the minimum delta that you want to detect in your A/B test, right? And there are a couple of constants here, which are type 1 error and type 2 error. So usually we assume type 1 error, which is alpha, to be around 0.05 and type 2 error to be around 0.2, right? So you can try to change these numbers, but usually these are the defaults that everyone uses, right? Now, with this, you can go ahead and start the experiment, right? But of course, in our company, in order to make sure that everyone is on the same page, we built a simple tool in order to sort of explain how n changes if you change mean and variance, right? So, if mean is starting from 0 till, let's say, 1 or something, then you can see that on the y-axis, n is changing, right? So, if variance is high, you can see that number of users required is also high, right? Yeah, this is about sample size. Now, let's start with the challenges that we faced. So, I'll start with the first one, how to assign users to experiments, right? So, in our earlier setup, we used to have static audience for A/B tests, right? To give an example, people used to take up, let's say, 3 million users for some experiment, and they used to assign this for an experiment. But of course, not all of them will open the app, right? So probably around 500k users would open the app and they would work with that, right? But there are a couple of issues with this approach, right? So the first one is brand new users cannot be part of the experiment as soon as they sign up, right? And the other thing is, it is also dependent on the sampling strategy, right? So if someone picks those users who are pretty active, who can bias the experiment, then obviously you cannot trust the results, right? So that's why we had to move away from static audience to dynamic audience. So this was the first challenge. And what is the solution to this? Well, you can start with some simple solutions. First one is directly use user ID and take mod and use some simple idea, like if mod is less than or equal to 2, assign it to variant, otherwise assign it to control, right? 4 to 2, right? This simple idea is used in most of the places, but it has some issues, right? The first one is it has hard coupling with the user ID generation process, right? Probably, all the users in California state, they have some pattern, right? We don't know about that, right? Or probably it also depends on the kind of users who joined when some offer was running, right? So we cannot assume anything when it comes to user ID generation, right? So that's the reason why we could not use user ID, while taking mod, right? Here is a simple example. So to fix that, what we did was we used a hash function which gives random values. So we pass user ID through a hash function, which is a Marmatri hash in this case, which is a non-cryptographic hash function. It takes an input and gives a random output, right? So this simple idea makes sure that user ID is not used directly, but indirectly, right? Now, what are the conditions? The only condition here is that it should give uncorrelated values, and it is simple to prove, right? Using this simple Python library, we are proving that, just by changing one single character, the entire output is changing, right? Which is what is desired out of these hash functions, right? So this simple idea helped us assign user IDs to experiments, right? Now, what is the next challenge? So earlier we were using mutually exclusive audience for experiments, right? So what do I mean by that? So if a user ID, let's say 1, 2, 3, 4 is part of one experiment, the same user cannot be part of another experiment, right? Now, although logically it makes sense, but you will quickly run out of traffic, right? User traffic becomes a constraint here, right? So to explain this clearly, let's assume that this is an e-commerce app. I've taken Amazon example. Let's assume that we have different widgets, right? You have search widget, you have recommended for you, recently viewed, so on and so forth, right? So let's assume that we need around 15 million, 10 million users, so on and so forth for different widgets. But unfortunately, our DAO, which is daily active users, is, let's say, 20 million, right? So you do not have enough to conduct experiments in the first place, right? So that's why mutual exclusion idea does not scale, although logically it makes sense, right? So to explain this again visually, let's consider that this entire circle represents our user traffic. And if you were to take mod, then you can clearly see that you are separating users into different, you are putting users into different regions, right? That's, you have got 5 regions. Clearly this idea does not scale, right? So the solution we came up with was, let's again start with the user traffic. So instead of doing mutual exclusion, let's split the traffic along different dimensions, right? So instead of directly taking hash of user ID, let's add a salt to it, right? So if you add +1, then you will get user ID mod assigned to some value, right? Now we can split the traffic again in some other dimension with a different salt, right? So this time user ID will get assigned to different bucket, right? So what we are doing here is we are simply making use of the salt now to make sure that we split the traffic along different dimensions, which helps us create a lot of experiments, right? So keep in mind that these are randomized in nature, so we can still trust the results, right? Let's take an example. If a user ID calls the AB service, then this user ID will be part of, let's say, search widget, and the user ID belongs to, let's say, 500 bucket. Now the same user ID will be part of recommended for you widget, and the user belongs to 290th bucket, right? Now the same user will be part of recently viewed widget, and the user belongs to 602 bucket, so on and so forth, right? So with this clever idea, we can conduct a lot of experiments, and we can still trust the results, right? Now with this, let's move on to the last key challenge: how to assign users to treatment groups, right? So far we have not answered that question. So far we have talked about how to assign users to experiments, right? So now that we have assigned users to buckets and buckets to experiments, we still need to assign users to treatment groups, right? So probably we need to assign some users to control and some users to treatment, right? So so behind the scenes, our AB system should give homogeneous groups, right? What do I mean by that? So let's say if male is to female ratio is around, let's say 60:40 in control, then the same ratio should be maintained in treatment as well, right? Or let's say power users, if they are 10% in number, then the same should be replicated in treatment also, right? So this kind of behavior should be there in both control and treatment, right? So to do that, let's take a simple example. So we have done the first level of randomization, that is passing user ID through murmur3 hash with some salt, right? Now, let's assume that we need 8 buckets for an experiment, right? We have taken 201, 235, 345, so on and so forth, right? We have got 8 buckets. So one simple idea to assign these buckets to treatment is that, let's take first 4 buckets for control and the next 4 for treatment, right? Very simple idea. But the issue is that there is something called as crossover effect, carryover effect. So what do I mean by that? So it can so happen that the first 4 buckets were part of some other experiment in the past, and this new experiment can be biased by that experiment, right? So it is very hard to sort of prove that this bias exists, but it can happen, right? Similarly, the last 4 buckets, they could be part of some other experiment in the past. Because of that reason, it might get negative result, right? So it's very hard to sort of prove all these things, but it can happen, right? So to fix that, there is a simple trick. Again, we use randomization. So again, we pass users through a second hash function where apart from adding plain salt, we add, let's say, some experiment name, right? And then we take mod 2, right? Now what it does is, half of the users from each bucket would be assigned to control, and half of the users from each bucket would be assigned to variant, right? So essentially, we are randomizing again, and we are making sure that none of these treatments get an upper hand, right? So we can still trust this, right? So this simple trick makes sure that there is no bias between control and treatment, and you can start the experiment on the same day, right? So that's the whole idea, right? So now that we have this B system in place, let's talk about the last part, that is, you have run an experiment and you have got a couple of users logging onto the app, and you have a better recommender system built using, let's say, GPT-4, and you want to check whether number of orders per user in variant is better than number of orders per user in control, right? Let's assume that this is the primary metric or the North Star metric, and we want to prove that the distribution, that is number of orders per user in variant, is better in treatment when compared to control, right? Now, in this particular case, it seems like it's better than control, right? Because mean has increased, right? But how do we prove that? There has to be some confidence score attached to it, right? And also, it could have happened by chance also, right? Because probably in randomization also, probably some power users might have got added to your treatment. Again, very hard to prove, but there has to be some scientific way of proving that treatment is better than control, right? So this is where statistical significance comes into picture. So you take signal to noise ratio, where signal is difference in means and the noise is the standard deviation, right? So here the idea is pretty simple. If the mean is quite different, then obviously the distributions are different. But if the standard deviation is high, then there is a fat tail because of which there is an overlap. And you could argue that probably they are not same, right? So that's what is Wells test is doing behind the scenes, and you can directly use this T statistic, right? Now, the last part of the puzzle here is you convert T statistic to a p-value, where p-value is probability of obtaining a result greater than the observed value here, given that null hypothesis is true, and you take the final decision. That is, if p-value is less than 0.05, you say that you reject the null hypothesis. Why? Because you have scientifically proved that it is better than control, right? So what's the decision you take? You scale up the variant and make it as new control, right? And if it is greater than 0.05, you do not reject the null hypothesis. That means you do not scale up the variant, right? Cool. I'll end the talk with this simple defaults that people normally use. What should be the experiment duration, right? Obviously, it cannot be 2 or 3 days because there could be some day of the week effect. Yup. Sample size, we have already discussed. Static audience or dynamic audience, always go for dynamic audience and go for 2 level of randomization so that users get assigned to treatment and control so that there is homogenization happening correctly, right? So last couple of things. What's the impact that we created? So last year alone, we conducted more than 300 experiments. And the awesome thing is we got the important ideas that can improve our business metrics, and we doubled down on those ideas which further helped us improve the business metrics. Cool. Thank you.